Welcome back, philosophers, to the History and Philosophy of Science in 6 Easy Steps. This is your Week 2 intro video, which is also a recap of Week 1. So I want to start by just reviewing our assignments for Week 1 and how things went with that, and looking at kind of the takeaway messages from that, and then give you some keys and some tips for Week 2. But first, I just want to say that, and this is very important, when you're doing an online class, it's probably hard to think about it like this, but I am a real person here behind this class. I'm available to you a large portion of the time. There are some days when I'm doing my intern at Tolland and I'm not available, but for the most part, late afternoon, evening, and on the weekends even, email me with questions. Tweet questions at me, send me messages through Moodle, whatever, and I want to be here. I want to help you to get over the hurdles that you might be facing with even if it's just, say, submitting an assignment, something like that. Okay, so realize that there is a real human behind this that you can ask questions. Okay, now Week 1. So here's what we saw, and this is the graph that I had made last year. And basically, this is an exponential curve. So what we see is nothing much happening for most of recorded human history until we get to around the 1600s, something like that, and then something starts to change, and all of a sudden, kaboom, we get this explosion of progress, right? So that's what I wanted you to see with the graph. And I just want to show you a little different take on that. This is from Ray Kurzweil, who we'll be studying in Week 6. And he looked at a whole bunch of different sources. Now, these are all sources that described what they thought were the most significant events in the history of not just humans, but life. You'll notice here that the time before present on this graph goes way, way back. Way back. And so this is just significant events in the history of the universe, not even just life. Okay, so we're going back here to the billions of years. So things like the origin of life would show up on this graph. Now look at this though. It says paradigm shifts for 15 lists of key events. Now these are the lists here. These are his sources, which, by the way, make sure you cite. Some of you'll see that in the comments that I put on your assignments. Paradigm shifts. So we're talking about major events. Now this word paradigm we're going to get into a lot more technically next week. But for now, let's look at this. The time before present. So we've got, this is a logarithmic scale. 10 years before present, 100 years, 1,000 years, 10,000 years, and so on. And then time to next event. This really means the time between major changes or major discoveries as we get into more recent years. The time between major changes or major discoveries. Look what's happening here. The time is decreasing drastically, actually logarithmically. All right. So that's another take, and we're going to get into that more. This particular graph, we're going to talk more about it in Week 6. But that's another take on the graph that we saw. And that's what I wanted you to see. So what's happening when you get this explosion? Now let's talk a little bit about your papers, your essays. Now, first of all, how about some technical stuff? So some of the issues that we had with those. You'll see these on the comments on the rubric. Some of you have to resubmit that because you didn't meet the 60% minimum score on that. I'm going to click here on key discoveries, and I put in kind of an assignment as a student just to show you what the rubric looks like and stuff. First of all, when you're in an assignment logged in as yourself, make sure you read this rubric carefully. I know they're kind of a pain to read, but this is how I'm grading your work. So it's critical that you always read the rubric. In my teaching philosophy, if it's not in the rubric, it doesn't exist. I will not grade you on anything that's not in the rubric. And if you think that I'm doing that, then please let me know, because I need to stop. So I'm scrolling down through the rubric. Now I'm going to see my submission, and here it was just, here's my essay. And then I'm going to scroll down further, and you'll see where I've scored this thing. Now what I did is I pointed out some of the primary causes of loss of points on this assignment for you folks. Address alternate points of view. If you read the rubric here, and by the way, this rubric is linked to the Common Core State Standards, which are all SBAC and stuff like that. We want to address different points of view. Might people disagree with you on this? And some of you did this, okay? So congratulations if you did. If you didn't, you're going to need to do that on this assignment if you want a better score, and on future assignments. So maybe say like, well, maybe not all people would think this is true. This is one of the best, the most significant discoveries because blah, blah, blah. But I think it is because blah, blah, blah. Okay, that's what we're talking about here. Then, cite your references and give specific evidence. Cite your references. Very few of you did that. I'm not looking for like full-blown MLA. I'm not going to be taking off credit for that. Use the footnote feature and just put in a URL. That will be fine. Okay, so, but I need to know where you got this information. I need to know that you got it from somewhere and that you're giving them credit. And then give specific evidence for why this event was one of the most important in history. So give me a well-reasoned analysis. If you think it was fire, why? Maybe, and many of you mentioned fire, maybe because without fire we couldn't extract metals from their ores and we would still not even be in the Bronze Age. Before the Bronze Age, the only metals people had were gold, silver, and copper. That's where we'd be now. And they don't make very good tools because they're too soft. They're not rigid and strong enough. Okay, so that's the sort of thing that I want to see. And then under organization, make sure that you include an introduction and conclusion. Make sure the introduction hooks the reader in, makes them want to read further. Somebody said something like, I set up these criteria that to decide what were the most momentous events in science, and the decision was easy. Okay, and so here they are. And now, so something like that, saying like the decision was easy to make, that kind of piques my interest because I'm thinking, it doesn't seem like it'd be that easy. I wonder why it was easy. So I want to read on. So something to hook them in, conclusion, some kind of new insight to drive your point home, to drive your thesis home. Okay. And then the language, just make sure you proofread. And then do notice this though. I maintain the audience's interest by doing one of the following: varying syntax and sentence structure, using figures of speech, content-specific language. And then take a look down here for comments. Also look on your file, especially, if it's on Google Drive. You're going to want to take a close look at the comments there. So again, some of you mentioned fire on this, that fire was significant. Some of you mentioned, let's see, the printing press, penicillin. Oh, that's a big one. Wow, without antibiotics, our lifespans would be halved. Think dying at 35 of tuberculosis and so forth. Definitely a big one. Some of you mentioned DNA. Now, that's interesting because I would agree that DNA is one of the big ones, but the interesting thing is that many of the implications, other than in agriculture, like through Monsanto's genetically modified crops, other than in that application, there haven't been a lot of huge changes that have resulted, but they're coming. And that's what we're going to talk about in week 6 also. What is the future of science? We have a lot to look forward to. The printing press and writing. Those are two things that people mentioned, which, by the way, it's kind of hard to say those are scientific discoveries, but the line between science and technology is kind of blurry, right? And that's why I didn't require you to distinguish. But those two are interesting because when you look at this curve and you think about why does it look like this? What if this happened? What if, as the discoveries are made, they enable more discoveries? So like, let's say one discovery happens, right? And then 5 more discoveries are enabled from that. And then from each of those, 5 more discoveries are enabled, and so on. Then you could see how this curve would work. you would get this sort of progression, this explosion, a geometric progression. And some of you actually mentioned this, that with printing, with writing, that's what it enables. It enables us to write, to record things so that people can actually build on it instead of forgetting about it. Okay, so I think that's cool, because some of you got into some things that and talked about how, and somebody mentioned Newton too, how one person's discoveries would become the foundation for other discoveries, and that's what gets into the shape of this graph. Okay, just a quick word before we go to week 2 about the discussions. I would like you to use Twitter. You don't have to, but the reason I like Twitter is because it is global. It is literally getting involved in a global conversation, a global process. When you do #science, anybody in the world who looks up #science is going to see your tweet. But if you don't want to do that, then you don't have to, because you can just go to our forum on our Moodle site, and you can contribute that way. The one change I'm going to make here in the future is every time we do a discussion, we are going to reply to each other. So everybody's going to require to make one post and then one reply. All right? Now let's look at week 2. So in week 2, we are looking at a philosopher by the name of Thomas Kuhn. And he's one of my personal favorites. And he's also there's probably few people who would say that he wasn't, if not the most influential philosopher of science, then one of the top 3. And we're going to talk about 2 of those top 3 this week. But paradigm shifts, the Kuhnian view. How does science progress? Paradigm shift, according to Kuhn, and here's where I'm giving you kind of the secret decoder ring to this week's projects. Paradigm shifts means, to Kuhn, it means a change in worldview. Okay, so you used to look at things one way, now you look at things totally different. It's almost like a sort of conversion experience that somebody goes through. Let me give you an example. Before Antoine Lavoisier in the 1770s came up with his oxygen theory of combustion, what ruled chemistry in those times was something called the Phlogiston or Phlogiston theory of combustion. And according to this theory, when substances burn, they released something called phlogiston. And this stuff was sort of, think about it kind of as a black, greasy substance. Think about it as soot, really, I guess. It's released when things burn. So you burn a piece of wood, the smoke is kind of like the phlogiston. And this theory kind of made sense because things seem to lose something when they burn. You burn a piece of wood, a piece of paper, its mass goes down. You're left with ash. It's losing something. It also explained things. I mean, it explained a lot of things. It explained why all metals were metallic, shiny and ductile and conductive, because they all contained a lot of phlogiston. They were phlogiston rich. And if you burn a metal, what happens to it? It's not shiny anymore. You burn iron, it becomes iron oxide, which we know as rust. It's not shiny anymore. It's kind of powdery, kind of crisp. It's not ductile anymore. Why? It lost its phlogiston. That was really, it provided a whole way of looking at the world. Now, when Lavoisier came along, and he came along with a better theory called oxygen, where when things burn, they're combining with oxygen. That's what he said. They're chemically combining with oxygen, something in the air. It totally changed the way that people looked at the world, that chemists looked at the world. Now, Thomas Kuhn would say this: how does science progress? Well, most people think it progresses linearly, like it's an accumulation of knowledge that Lavoisier just built on the phlogiston theory, and then modern chemists are just building on Lavoisier, that Newton built on Galileo, and that Einstein built on Newton. But Kuhn would say, no. What really happened is that every time one of those revolutions took place, every time one of those major new theories, they got rid of the old theory. They totally got rid of it. So it was a total transformation. So it's kind of like instead of just adding data to your hard drive, you just delete it all and start over. Maybe not that extreme, but that's kind of like what he's saying. Now, when you read it, see if you agree with that. And I've got to kind of think about that myself because I just thought of that analogy. But it's a total change in worldview. Is this picture a duck or a rabbit? You'll see that Kuhn talks about that. Now, so that's your kind of key to what Kuhn is talking about here. Let's look at the specific requirements for this week. First of all, take a quick look at this video. It's only 15 minutes or so long. It's going to give you a quick overview of the history of chemistry, a lot of which Kuhn talks about. Oxygen, the play. This is part 1. You're going to watch this play that was created by the University of Wisconsin, and it's kind of an interesting take on who discovered oxygen. See, there were 3 guys back then who all kind of would have reason to lay claim to discovering oxygen. And the question of who actually discovered it comes up in Kuhn's arguments. So read the play, and then you're gonna write an essay about who discovered oxygen. The rubric is going to be the same as it was before, but make sure you read it again. So make sure you cite references from the play and stuff like that. Progress of science, readings, and essay. This is where you're going to answer this question, how does science progress? You're going to do it by reading from Thomas Kuhn's book. Now I'm going to click on this because I want to show you something that I made here. I made you a video. It's fairly long. It's almost a half-hour long, but it's going to be worth your time because these readings are not easy. This is a philosopher writing here. Now, that probably makes it sound worse than it is because he's actually a good writer, and it's a short book, but you're going to be reading 2 chapters. I would suggest reading this where I kind of go through a method. It's a method for reading technical stuff, for reading difficult stuff, and in the process I give you a lot of tips about Kuhn's views. So I would suggest reading that. Notice here I talk about the audio version. If you scroll to the top, toward the top of the Moodle site, you'll see that I've given you some resources there which include audio files, someone reading Kuhn's book. So if you'd rather listen to it, that might be good. And again, you're going to submit an essay here, and then we're going to have a discussion about Thomas Kuhn on the internet. So this is either going to be on the forum or on Twitter, and again, you're each going to make a post and then you're going to discuss it. And whoops, I almost forgot. Each week I posted these little Friday feedback surveys. Please go on there, give me some feedback. How are things going? What could I do better? What could I change? What's been helpful? What hasn't been helpful? What have you enjoyed? What haven't you enjoyed? That sort of thing. Think about it as what's going well, what's not going well. And I will respond to those in the sense of I'll pay attention to it. Okay? So make sure you do those Friday feedbacks. Here's the Kuhn audio. If you click on here, you'll get the audio files. Now there's just a bunch of files, so if you go down into the assignment here, it will actually tell you which files to look at for the required chapters, or at least where to start. Okay? So, sorry, here's the assignment. That is a preview of week 2. The other thing I want to show you is if you want to take a look at your grades, just click this over here, grades. And you'll see your grades. Now, if you see a 0 there, now you might have noticed that in the course expectations and stuff I said there were no zeros in this course. So those zeros just mean that you still have to turn that in or you have to resubmit it. So you need to get at least 60%. So what's going to happen if you have any zeros, then you simply won't get credit for the course at the end of the course. Okay, in order to get credit, you have to get at least a 60% on every assignment. Now the bright side of that is you get as many tries as you want to do that. Okay, so if you haven't achieved a 60% yet, for example on the week 1 assignments, then you can still do so. Just resubmit. All right, I hope you enjoyed week 1, and I hope you'll enjoy week 2 at least as much. Week 3 is going to be pretty cool as well, and I'm pretty excited about the future of this course too, because later on, I've decided to change one of the weeks, and that is the influence of science on society. This one wasn't particularly interesting last time, so I'm going to switch this one up, and I think you'll like what we do with it. So again, if you have any questions, please just email me, tweet at me, whatever. I am here for you. Okay? Great.